Hello everyone, welcome to the chemistry class. This is the lecture number 2 of our online class series for class 10th chemistry. Hope you enjoyed the last lesson and learned a lot. In the last class we had discussed about the introductory part for the periodic table. We discussed about the various groups, the main groups, the representative elements. Then we had a short introduction of the transition metals as well as the noble gases. In this class, we shall move further into the chapter, and we today will discuss about the periodic properties. It is just a beginning. We'll start learning about the periodic properties, and in the upcoming classes, we will see the variation of properties in the periodic table. Let us begin now. The first topic of today's class is periodicity. What is periodicity? Before learning that, we should know what are periodic properties. These are the properties that reappear or repeat at fixed or regular intervals. They repeat after a certain time or a certain interval. They are called the periodic properties. With respect to the periodic table, if these periodic properties are repeated or shown by the elements, they will form a particular trend, or we can say there will be some variations of the properties. We will learn about these in the further chapters and the further topics to be discussed. So this type of reappearance of periodic properties of elements are called as periodicity of the element. Now the question may arise, what is the cause of this periodicity in the periodic table of elements? It is due to the recurrence of similar electronic configuration, that is, the number of valence electrons is same in the elements belonging to a particular group. Same group elements are always having the outermost number of electrons equal. Let us see that with the help of an example here. We have these elements belonging to the group number 1, lithium, sodium, potassium and rubidium. I have mentioned the atomic number alongside. If we write the electronic configuration of each of these, you will find that the valence electron is always same, that is, in this case 1. Due to this reason only, that the outermost electrons, the number of valence electrons is same, the same group elements show similar properties, which leads to the formation of a periodicity. Let us now move to our next topic, shells, orbits and valency. First, let us learn what is an orbit. For explaining what is an orbit, I have shown here a diagram of an atom of argon. It is a noble gas. Argon contains 18 electrons. Now you can see the atomic structure over here. It is divided into 3 shells, that is K, the next one L and the last one M. All these 3 shells are filled with certain number of electrons. In this case it is 2 electrons in K, 8 electrons in L and 8 electrons in M. These electrons are always moving in fixed path. These are the paths only which are known as orbits. Here is the definition. Electrons revolve around the nucleus in definite circular path or fixed circular path, which are called as orbits or shells. Now, with regard to a particular group, this number of shells form a particular periodicity. Let us see that. Down a group, if we follow a particular group only, the number of shells increase as we move down a group. And across the period, if you move left to right in the periodic table, then the number of shells remains the same. This fact you have to remember. Down a group, number of shells increase, and across a period, number of shells remain same. Due to this fact, we have already learned this or memorized this in the last lecture itself, that is period number equal to the number of shells. For this to be more clear, here is a table. This is from your textbook itself. Elements are written there. These are the elements and they are showing the number of shells. This particular group number is of halogens, number 17 group 17th, that is of halogens. You can see the electronic configuration written over here. Now here you can see the number of shells is increasing. As we go down the group, number of shells is increasing here, 2, 3, 4, 5, 6. That is, as we go down the group, the number of shells or number of orbits increase. Having learned about the orbits or shells, we shall move further towards the next topic called as valency. In simple terms or in plain language, we can write valency is the combining capacity of an atom. It is the simple definition. To make it more clear, we can further elaborate this definition as it is, or valency is, the number of electrons accepted, donated, or shared. It can be accepted, donated, or shared by an atom. Whatever number of electrons are accepted, donated, or shared by any atom, it becomes its valency. For making it further clear, here we will one by one refer to these structures of atoms. Remember that we have to pay attention only to the outermost valence shell. In this particular diagrams, the outermost electrons are shown in the red color. The first one now, sodium atom. Here valency is 1. Why the valency is 1? The question is why the valency is 1, or how we can understand the valency is 1. So for this you have to see the outermost electron, only one electron is there in the outermost shell. For this, to make 8 electrons, it has to accept 7 electrons more, because as per the octet rule, the outermost shell should have 8 electrons. Here only 1 is there, so it needs 7 more to make it 8. Another case is also there. If this particular electron is easily lost by this atom, if this atom loses 1 electron, then the outermost shell will be changed. From this M shell, it will become L shell. The innermost, as the structure of atom, the nucleus is in the center, followed by K shell, followed by L shell, and then M shell. So now if the M shell is not having any electron, then it will not be there. So then K and L shell will remain in the atom only. So in this case also, the M shell, which is having 1 electron, will lose that electron, and it will not be a part of that atom furthermore. That is why sodium atom is having 1 electron to be lost, and therefore 1 is the valency for sodium. Similarly, for magnesium, here also the outermost electrons are 2 in number. So for magnesium, 2 electrons can be easily lost compared to accepting 6 electrons, because 2 are already there. To make it 8, it has to accept 6 electrons. That is pretty much difficult compared to losing 2 electrons. That is why magnesium is having valency of 2. It is written downside. Next one now, that is aluminium. Similar case, 3 electrons in the outermost shell. So losing 3 electrons is easier compared to accepting 5 to make it, or to complete the octet. So this is not a good option. So easily aluminium will lose 3 electrons. Furthermore, as we move downwards in the second row of this diagrams, this is phosphorus, sulfur, chlorine, and argon. Now phosphorus valency is written 3 to sulfur 2, chlorine is 1, and argon is having 0 valency. That one by one let us see. First one now, phosphorus. Phosphorus is having 1, 2, 3, 4, 5. 5 electrons in the valence shell. Now already 5 electrons are there. And how much more is needed to make it 8? That is 3 more are needed. So it has two options. Either it loses these 5 electrons. Another option, it accepts 3 more electrons. So losing 5 is not a good option compared to accepting 3 electrons. You compare the numbers. So that is why phosphorus is having the valency of 3. Similarly, sulfur. Sulfur, you can see here, the outermost number of electrons is 6. 6 electrons are already there. So for completing the octet, it needs only 2 more electrons. That is one option. Another one, it can lose, not so easily, it can lose 6 electrons. So which one is better option, accepting 2 electrons or losing 6 electrons? So as per the number, is this one is less. So it will accept 2 electrons from another atom. That is why sulfur is having the valency 2. Chlorine, you can see outermost electrons are 7 in number. Easily it can accept 1 electron from outside, from other atom, and complete its octet. That is why chlorine is having, chlorine valency is 1, because minus 7 or losing 7 electrons is not a good option. In case of argon or all the noble gases, you see here the octet is already filled. All 8 electrons are there in the outermost orbital. So its octet is already filled. It does not need to lose or gain any number of electrons. That is why the noble gases, all the noble gases are having the valency 0. Let us have a look at the definition once again. Valence is what? It is the number of electrons accepted, donated, or shared by an atom. So by this diagrams, it should be clear now. In this first row, the elements are donating, they are losing their electrons. So whatever number of electrons are lost by any atom is the valency. Similarly, in the downside here, the electrons which are gained or accepted, here these are accepting the electrons. So whatever the number of electrons are accepted or they are lost. That becomes the valency. Now what is the case of sharing here? For instance, just for an example, if we see here sodium and chlorine needs one electron to complete the octet. Here in the case of sodium, it needs to lose one electron, so this electron can be easily given to chlorine, that is the outermost electron will be shared by both of them and a new compound called as NaCl will be formed. So that is a kind of bonding. We will refer to this in details in the upcoming chapter. After finding the concept behind the valency, we will now learn how to calculate valency based on the atomic number. This topic is pretty much important as questions are repeatedly asked in the board exam. You will be given the atomic number and you have to write down the valency. So let us begin here. If as I told you here, the valency depends on the number of electrons in the outermost shell. It can be calculated in these methods. Two methods are there. If the number of valence electron is 1, 2, 3 or 4, that is if the valence electrons are less than 5, 1 to 4, then that valence electron, whatever the number of valence electron is there, it will be equal to the valency. If the number of valence electron is 1, then valency also is 1, that is the valence electron. If valence electron is 1, valency is 1. The valence electrons are 2, then valency is 2, and so on. The second point here, if the number of valence electron is either 5, 6 or 7, then what we have to do? Then we have to subtract that number by 8. 8 because related to the octet rule only, because outermost electron should be maximum 8 in number. So we will subtract this by 8, and by subtracting we will get the valency. So here in the short we can write this as valency is equal to 8 minus number of valence electrons. This when we have to do when the valence electrons are 5, 6 or 7. Otherwise valence electrons is equal to valency. If the valence electrons are less than 5, we have to follow number of valence electron equal to valency, otherwise the second one. Having learned how to calculate the valency, we will now see the trends in valency, or this is related to periodicity itself. Let us see here down the group. If we move in a particular group downwards, then the valency remains same because of the equal number of valence electron. As we have seen, valency depends on the number of valence electrons, and in the same group the number of valence electrons are always same. So the valency also remains same for a particular group. Second thing, across the period, as we move left to right in the periodic table, the valency first increases from 1 to 4 and then decreases to 0. That is, the 0 will be for group number 18. That is extreme right of the periodic table. So as we move from left to right in the periodic table, the valency increases from 1 to 4 and then it ultimately decreases to 0. That is for more details, let us see group number 1 will have the valency 1, group number 2 will have the valency 2, then group number 13 will have the valency 3, group number 14 will have the valency 4. This much is simple, followed by group number 15 will have the valency 3. I have done 8 minus 5 because the outermost electrons are 5 in this case. Group number 16, it will have 2 electrons. Group number 17 will have 1 electron, and finally group number 18, that is inert gases, it is already having 8 electrons, so 8 minus 8 is 0. Okay students, having been covered a sufficient part of the chapter, it is time to see now the solutions to the exercise given in the chapter, that is in-text questions on the page number 5 of your textbook. I'll be reading through these questions. If you want, you can note the answer, anyone if you need, or you can pause the video and take a screenshot if you need so. The theoretical questions I'll not go into much details. Most of them are directly written from the book itself, that is language based, so you can learn that. The ones which need some explanation, I'll go into details. The first one is language base itself. State the modern periodic law. We have covered that in the class. The periodic properties are repeated in that based on atomic number. Next one, the scientist who stated the law was Moseley, Henry Moseley. How many groups and period does the modern periodic table have? 18 groups and 7 periods. Second question, what are the horizontal rows and vertical columns in a periodic table known as? They are called as periods. Horizontal rows are called periods and vertical ones are called groups. Question 3, periodicity is observed due to similar dash, that is electronic configuration. Question 4, they're asking a periodic trend. How does the electronic configuration change in a period? As you move from left to right, what is happening there? The number of valence electrons is increasing, that we have seen in the class itself. In a group, what is happening? The number of valence shell is increasing. Here it is written there. Across a period, the shells remain the same, but valence electron increase by 1. In a group, what is happening? In the group, number of valence electrons are same, but the number of shells are increasing. Question number 5. Name 2 elements in each case. Now here, to each I have written. You can also write as from the periodic table. Any of these you can write. Like alkali metal, to have written sodium, potassium. Any other also alkali metals, any of those you can write. So these are name the following only. You can see the answers itself. Question number 6 now. Elements of group 1 and 17 both have valency 1. Now group number 1 is having elements with outermost electron 1. So whatever the valence electrons is equal to the valency. So that is written here. The number of electron present in outermost shell is 1. So it can easily donate 1 electron. So that is why group 1 is having 1 valency. Followed by the group 17. Here the outermost electrons are 7. Therefore it can not lose 7 electrons easily. So we have to do 8 minus 7, that is it can accept 1 electron. That is why in group number 17 also valency comes to be 1. Question number 7 is correct the statement, just point out the mistakes. I have underlined there wherever the change has come. You can see it for yourself. Question number 8 is also theoretical. You can see the answers. If you need, you can pause the video and note down. Question number 9. Name 2 elements which you would expect to show chemical reactions similar to calcium. Now calcium is having a valency of 2. Its atomic number is 20 and it belongs to the second group. Because its valency is 2, therefore the 2 other elements which will show similar reactions, they will also be having valency 2, or they will also belong to the same group. Calcium group elements, any other 2 elements we can note down. So this is from the group number 2. Group number 2, any 2 elements name you can write. In my answer I have mentioned beryllium and magnesium. They are belonging to this particular group itself. So here beryllium, magnesium, calcium, then strontium and so on, barium and so on. Any of these 2 you can write. So the answer is there, beryllium and magnesium so show similar properties. Why they show? Because they are having the 2 electrons in the outermost shell similar to calcium only. Just name the following, it is there, but you have to name from the first 20, from atomic number 1 to 20. Any of those elements you can include in your answer. The answer itself is there. You can note down the answer. Question number 11. Fluorine, chlorine and bromine are put in one group. All these are in the group number 17. So the question they are asking, what are the properties on which basis they have been put in the same group? So these properties, this part 1 of this question, I will not go into details in the upcoming class as we learn the variations in the periodic table. After that it will be more clear. So for now I am not explaining this in details. Surely I will come after completing the remaining part of the chapter. Question number 11, second part, what is the common name? Already we have learned that it is called halogens and they are salt forming. Question 12, what is the main characteristic of the last element in each period of the periodic table? Every period, last element is always from the group 18 and they all are inert gases or noble gases and they are chemically unreactive. Question 13, according to the atomic structure, what determines which element be first and which is the last? The first element and last element, which element is first and which is last? What is the deciding factor? The answer is number of valence electron. If valence electrons are 1 in number, the group number is also first. If valence electrons are 8 in number, then the group number will be 18. That is the last group. Question 14. How does the number of valence electron and second part valency vary from moving left to right in a periodic table? Which period? Third period. In the third period, that is the typical elements only. So they are asking number of valence electrons. If you move in a particular period left to right, the valence electrons are increasing from 1 to 8. The second part, valency. What is the case of valency? Just today only we have discussed this thing only, that valency, what is happening? First it is increasing from 1 to 4 and then it is decreasing to 0. As you move from left to right across a period, valency increases from 1 to 4 and then decreases to 0. That same is written here in the answer. Question 15, you have to name the type of element, not the element, the category name you have to write. First one, outermost shell is complete, that is in noble gases. Second, incomplete. Incomplete is for representative or main group element. It is from group number 1 and group number 1, 2, then 13, 14, 15, 16. All these are representative elements. If you followed the last class, you would be knowing this. Two outermost shells incomplete, not single outermost, two outermost, that is, they are called transition elements. Then fourth part, one electron short of the octet, means they are having 7 valence electrons. Then the 7 valence electrons are for halogens. The next question, the fifth part, 2 electrons in the outermost orbit. 2 electrons are in the outermost orbit for group number 2 and they are called alkaline earth metals. Now this is an application based question. Based on a knowledge you have to answer. Question number 16, an element has 2 electrons in the n shell. N shell is K, L, M, N. Now here 2 are there, that means earlier ones will already be filled. So this makes up 2, 8, 8, 2. Total is coming to be 20. That's the atomic number Z for that particular element we have calculated. See, by the number of n electrons itself and n shell electrons itself, we have calculated the atomic number. So first one is atomic number is 20. How we calculated? Just I showed you with the help of electronic configuration. We can calculate its position. Now if the valence electrons are 2 in number, whatever the valence electrons are there, that will become the group number. Earlier class, last class, lecture 1, we had discussed this. Valence electrons show the group number. Now as I had written the electronic configuration, how many orbitals are orbits are coming there? 4 orbits are coming, because 4 orbits are coming, or 4 shells are there. So this number of shells show the number of periods. So that is why it is from the fourth period. Outermost electron is 2, that is why it belongs to the second group. Outermost electron shows the group number, total number of shells show the period number. Next one, it is a metal or a non-metal. Now last class itself we have discussed, in the main group element, the first and the second group are all metals. So that is the answer is, it is a metal. Next one, state the name assigned to this group. All the second group elements are called alkaline earth metals. And as the atomic number is 20, so extra question from my side, what is the name of this element? So easily, if you know the atomic numbers, a minimum 1 to 20 you should learn atomic number and their names. So if the atomic number is 20, that is calcium. So this question is framed about calcium only. Now the question we had discussed, I had asked you to solve in the last class. I got one answer in the comment. That was a nice attempt. Answer the following in respect of the element sulfur. So sulfur, you have to write the answer related to that. Sulfur is having the atomic number 16. So the electronic configuration they are asking, it will be 2, 8, 6 for different shells. Next one, to which group and period it belongs. Now if 2, 8, 6 is the configuration, so it belongs to which group? 6th group. This is the group number. How many shells are there? 3 shells are there. 3 shells are there. So its period number is also 3. Clear? Next one, what is the valency? Outermost electrons are, or the valence electrons are 6 in number. So we'll subtract it by 8, we will get 2 2 as the valency. Next one, it is a metal or a non-metal. Now it is belonging to which side of the periodic table? It is belonging to the 16th. It is belonging to the 16th period. Now earlier class I told you, as you move to the right of the periodic table, left hand side are the metals only, group number 1 and 2, and followed by the transition metals, followed by the non-metals. In between some metalloids are also there. So in the group number 16, that is sulfur, is a non-metal. Answer of this is non-metal. Answers are on the next page. Here all the answers are there. Question number 5, is it a reducing or oxidizing agent? This is based on redox reaction. You would have studied in earlier class, 8th and 9th already. You have learned this topic. Reducing agents and oxidizing agent, that is from reduction and oxidation. So it is an oxidizing agent. How it is an oxidizing agent? Sulfur is having outermost how many electrons? Only the outermost shell I am telling, that is 6 electrons are already there. It has to accept 2 more electrons to make it an octet. So when any atom is accepting electrons, then it is an oxidizing agent. If any atom is losing any electrons, then it is a reducing agent. So in this case, electrons are accepted. That is why sulfur is an oxidizing agent. Next one, give its formula with, sorry, the question is wrong, with hydrogen. The formula with hydrogen is H2S, because sulfur is having the valency of 2, hydrogen is having valency of 1. We'll transpose this and we'll get the answer H2S. Hope the questions are clear to you all. Any doubt you can ask in the comment section. Thank you.